All right, so if you're an architect working in AWS, you have definitely stared this decision down before. You've got services that need to talk to each other, but which messenger do you pick? You've got SQS, SNS, EventBridge. They all sound kind of similar. They all promise to decouple your system. But you and I both know that picking the wrong one can lead to some serious headaches, like performance bottlenecks or code that's just way too complicated. So let's actually dig in and build a really clear framework so you can make the right call every time. But first, let me ask you a question. Just take a second and think about your system right now. Is it a fortress, or is it more like a house of cards? You know exactly what I'm talking about. That feeling where if one little service hiccups, the whole application just comes tumbling down. It's a pain point pretty much every architect has had to deal with. And that whole house of cards feeling, well, it usually comes from one specific place: the tightly coupled chaos of older, monolithic-style designs. I mean, just think about it, right? Service A makes a direct API call to Service B. If Service B is slow, or even worse, if it's completely down, what happens? Well, Service A is just stuck. It's sitting there waiting and it can't move on. Now imagine that kind of dependency happening across dozens of services. That's what we call brittleness, and that is the chaos we need to escape from. So, how do we escape? We do it by picking the right messenger. So let's crack open the Architect's Rulebook and take a look at the tools that AWS gives us to solve this exact problem. And the very first rule in that book, the one written in big, bold letters, is this one. Now, this isn't just some friendly suggestion. It's really the foundational principle for any modern resilient architecture. If you want to build systems that can scale and survive failure, you have got to break those direct links. You have to decouple. Okay, so our first tool for the job is SQS, the Simple Queue Service. You can think of this as your classic, super reliable workhorse. Let's imagine an order processing system. Your website takes an order, and instead of calling the processing service directly, it just drops a little message into an SQS queue. Simple. The processing service can then just pick up that message whenever it's free. The key thing to remember here is one-to-one. One message reliably delivered to one consumer. It's absolutely perfect for basic decoupling and for buffering work. So that one-to-one thing works great for separating the order intake from the processing. But what happens when a new order comes in, and now all of a sudden your inventory system, your shipping service, and your analytics platform all need to know about it, like right now? Having all of them trying to pull from the same SQS queue, well, that would get messy and inefficient really fast. And that's where our second tool, SNS, comes into the picture. Simple Notification Service is built for exactly this fan-out kind of job. It uses a publish-subscribe model, or pub-sub. Your order service publishes one single message to what's called an SNS topic, and bam, SNS instantly pushes that message out to all of its subscribers. Inventory, shipping, analytics, they all get the notification at the same time. It's a really powerful one-to-many communication pattern. Okay, but let's add another layer of complexity here, because let's be honest, the real world is never that simple. What if you've got a special fraud detection service, but it only cares about orders over $500? Or maybe you have a regional shipping service that only needs to know about orders coming from Europe. You definitely don't want to spam them with every single order message. You need smarter routing. And for that kind of smart routing, we turn to Amazon EventBridge. The best way to think about EventBridge is as the intelligent traffic cop for all your events. It's this central event bus where you can create rules that actually look inside the event itself, at the content. You can write a rule that says, hey, if this is an order-created event and the order total is greater than 500, then send it over to my fraud detection service. It's not just broadcasting anymore, it's filtering and routing with some serious precision. Okay, let's just pull this all together for a second. When you lay them out side by side, the differences become super clear. For the consumer model, right? SQS is that classic one-to-one polling. SNS is a one-to-many push. And then EventBridge gives you this incredibly powerful many-to-many rule-based push. And what about filtering? Well, SQS has none. SNS has some pretty limited filtering you can do on message attributes. But EventBridge, that gives you advanced filtering based on the actual event content. And all this leads to the most important part, the primary use case. Use SQS for simple decoupling. Use SNS for fan-out. And use EventBridge for intelligent event routing. So picking the right tool, that's step one. But even with a perfectly decoupled system, things can, and they will, go wrong. So now we need to talk about how we build for resilience, how we prepare for failure. This is a mantra that every single senior architect lives and breathes. In these big, complex, distributed systems, components are going to fail. Networks will have blips.
APIs will time out. It's just a fact of life. So the goal isn't to somehow prevent failure from ever happening. That's impossible. The goal is to build a system that can handle it gracefully when it inevitably does. So let's play out a scenario. An order message gets delivered from our SQS queue over to the shipping service. But, oh no, the shipping service's database is down. It can't process the message. It fails. So what happens to that order? Does it just, vanish into the digital ether? No way. This is where we bring in the concept of a dead letter queue, or a DLQ. A DLQ is basically our safety net. It's a completely separate, dedicated queue where messages that keep failing to get processed are sent. This does two amazing things. It prevents you from losing data, and it stops one bad poison pill message from jamming up your entire system. And you can see the whole life cycle right here. First, the message processing fails. The system doesn't just give up on the first try. It's configured to automatically retry. So maybe it tries 3 times and fails every single time. Okay, after that last failure, the message is automatically shuffled over to the DLQ. Now it's safely out of the main flow, and your developers can go in, take a look at that specific failed message, and figure out what went wrong, all without disrupting the life system. Now, beyond DLQs, a truly resilient system really thinks about these 3 concepts. First up, idempotency. It's a fancy word, but it's a critical idea. It just means that if a retry processes the same message twice, it doesn't cause a problem, like charging a customer's credit card 2 times. Next, we have retries, which we've already seen are your first line of defense against those temporary transient errors. And finally, schema evolution. You have to plan for the future. The data structure of your events will change. Schema evolution is all about managing those changes so you don't break older services that are still expecting the original format. Okay, so once you've really mastered these fundamentals of resilience, you haven't just built a robust system, you've built a foundation. And on top of that foundation, you can start to implement some truly powerful, really advanced architectural patterns. Here are 4 patterns that you should definitely keep in your toolkit. We've already talked about fan-out with SNS, where one event kicks off a bunch of parallel workflows. Then there's asynchronous processing. This is all about the user experience. You offload a heavy task, like encoding a video, so your user gets an immediate, okay, we got it, response. The saga, or choreography pattern. This is how you manage those really complex, multi-step transactions, like a whole travel booking process, without having one single point of failure. And finally, you can use your event stream as a perfect audit log, an unchangeable, chronological record of everything important that happens in your system. This is an absolute goldmine for security and compliance. So after all of that, we come all the way back to the central question. How do you make that final choice? Honestly, it boils down to these 3 simple questions. Is your main goal to just simply and reliably decouple 2 services? Use SQS. Do you need to notify a whole bunch of different systems about one single event? That is a job for SNS. Or do you need to intelligently inspect, filter, and route events based on what's inside them to all sorts of different targets? Then you absolutely need the power of Event Bridge. And I'll leave you with this one last thought to chew on. When you're making this decision, you're not just connecting services together. You're actually making a fundamental choice about the future of your architecture. Are you just putting a patch on today's problem? Or are you laying the foundation for a system that's resilient, that's scalable, and that's evolvable, one that can adapt to whatever comes next? The choice is yours.